All right, we're talking about Turing machines. We're going to do a few more examples. I know it's a lot of examples, but these things are complicated, and there's some different strategies that I want you all to be familiar with. The strategies that we've talked about so far involve blanking out letters, which can work in some simple examples. In more complicated examples, it's better to mark them, like instead of making them blank, turn them into something else. So you can tell the difference between a truly empty spot versus a spot that used to have a letter that you marked off. I'm going to do one more example next, which needs a slightly more complicated form of marking. This is everybody's favorite example of a non-context free language. A to the N, B to the N, C to the N is not context free, but you can make a Turing machine that accepts this language. And the idea here is maybe I'll refresh your memory about examples that we've just done more recently. Remember when we did A to the N, B to the N, if we had something like this, the idea was you blank this A out and then you run down to the end and then you blank this B out and then you run back to the beginning, blank this one out, blank this one out, go back, blank this one, blank this one. We also had this example of balanced brackets. In that one, you start with a right bracket and then you mark it off. We turn it into an X. And then you go back and mark off the matching left bracket and then look for the next right bracket. Mark off the next matching left bracket. Here, it would be that one, and then you'd be done. For this one, you're going to have something like A, B, 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 C, C, C. Now, in this case, we need to mark off the A, then go find a B, mark that off, then go find a C, mark that off, and then go back to the beginning. It should be similar to this one here. It turns out because of you're going to have to be inserting X's sort of in the middle of the string. In this example, we're not going to mark with X's. We're just going to mark by changing A into A bar. So A is what it originally looks like. A bar is going to represent one of these A's that we've already read and matched off with another a B and a C. So we're going to mark by changing A to A bar. We're also going to, mark off when we want to mark off a B rather than just changing it into an X. I'm going to change it into a B bar, and when I mark off a C, I'm going to change it into a C bar. It's because of the procedure that we're going to use for this marking. If you start changing these to X's, then you'll lose track of where your block of A's, block of B's, block of C's used to be. So this is like a slightly more sophisticated marking strategy. Of course, you could have done that in these examples also, only it really wasn't necessary. This is a more complicated language, and it turns out this kind of marking is necessary in order to make the same strategy work. But let's see if we can do it. So my idea here, let's just do step by step, or at least according to what you see on the tape. What will happen if we try to check this string on our Turing machine? The idea is we're beginning here, and I'm going to mark this A first, change it to an A bar, and then everything else will be the same at this time. Right. So right now the head will be right here, and I need to move to the right until I get to a B. Maybe I'll try and write these steps down. I'm going to mark A to begin with, all right? And then I'm going to move to the right through any other A's. Move right through A's. And then hopefully I'll end up with a B, and then I'm going to mark a B. So in the next step, the head will have moved this far over, and then this B will turn into a B bar. And then I have the rest of this stuff. All right, and then I'm going to continue moving to the right through any B's. Move to the right through B's. And can I just say, eventually, when we are doing this in later steps, you might have to move through some C bars, right? Because some of these C's may have already been marked off. And in that case, I'm going to move through all the B's and also all the C's which have already been marked. So I'm going to say move through B's and C bars. And actually, I could have said that in this step, right? When you're moving to the left to look for the next B to mark, you may have to go through some B's which have already been marked. So you're going to move to the right through any A's and also through any B bars. So move to the right through A's and B bars, right? And mark a B. All right, anyway, this one, move to the right through any B's and C bars, and then you're going to mark a C. By mark, of course, I mean change it into a C bar. All right? And then once you've marked a C, you can go all the way back to the beginning, So now I'm going to move left through. How do you know when to stop? Well, actually, you should stop when you get to an A bar, because that means you made it all the way back to the beginning, and then you'll move one step to the right. What am I going to go through as I move to the left? Sorry, I didn't write that step. Once I mark the C, it now looks like this, right? And as I go to the left, what do I need to move through? Well, I might have to move through C bars, and also Bs, and also B bars, and also As, but that's it. Not moving through A bars. So move to the left through C, C bar. Well, actually, not C. The only C's should be to the right of where I am right now. So don't move through C's. C bar, B, B bar, A. Right? When you see an A, when you finally get to an A bar, that means you actually made it back to the beginning, and then you should just move to the right. So when we see A bar, keep it as an A bar and move one position to the right. And then loop. Then you're back at the beginning, and you should go back to that step, right? This is the basic structure of how this machine works. So after this step, it will now be pointing at this A, and we mark that A. So next step, it'll say A, and then A, B bar, B, B, C bar, C, C. And then it'll start to move to the right. It'll go through this A. It'll go through this B bar. That's what I said. And then it'll mark the next B. So it'll go A, A, B, B, C bar, C, C. It just marked that one. Now it'll do this. It'll move to the right through any B's and C bars and mark the next C. So next it'll say A, B bar, B bar, B, C bar, C, right? And then it'll move itself back to the left. This step is not changing the tape at all. All right, etc. Can I just say, by the time you get to the end, everything will be marked, right? Everything will be marked. You'll find yourself at the end of the string. Actually, by the time you do this last part, it says when we see A bar, move to the right and continue. Now, if you follow these directions here, it'll go back to there. It'll see an A bar, and then to the right will immediately be a B bar. And so, from the first step, in step 1, if we see B bar, then actually that's our cue that we are done, right? Now, it's not necessarily totally done, but if you see a B bar here, that at least means that you have finished reading through all the A's. Now, the one last thing you need to do is to verify, make sure that there are no extra B's left over that are still unmarked, because that could happen when you're doing this procedure, and also there are no extra C's that are left over that are still unmarked. We have to make sure we're basically, at this point, we've checked up through here and verified that all of the A's have been marked. But now you got to go through to the right until you get to the end and make sure everything looks the way it is. So what I'm going to have is basically 2 steps here. We're going to move to the right through B bars, just making sure that it's all B bars and no ordinary B's are left over. Then when we see C bar, that means after you have gone through a bunch of B bars, seeing no B's, then when we see a C bar, we switch, and from there we try to go through and see only C bars. So when we see C bar, I think I'm running out of room. Can I just continue over here? Sorry about that. When we see a C bar, we're going to move right through other C bars, right? And if you finally get to blank, that means you're really done, and everything must have been marked properly because you checked it, right? So move to the right through C bar, and then when we see blank, accept. All right, and this is the idea in words of how this machine is going to work. Okay, let's translate this into various states for the machine. There is a starting state, which is, just going to say this is the starting state. I'll call that state 1. And then this is going to be a state. Move to the right through all A's and B bars, and then mark B when you see it. So that's a state. This is state 2. it's going to have a transition when you see a B, you write B bar, and then you go into the next state. So this right here is a state 3. Then we move to the left through blah, 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 and when we see this, we move to the right and go back to the beginning. So this is another state, right? This is, I'll call that state 4. And then this is the main loop here, and then there's like the end game, which involves another several states. So in step 1, if we see B bar, then we do this, move to the right through all B's. I'll call that state 5. This is the state where it's checking to see that all the B's have been marked. And then when we see C bar, we have to move to the right through all C bars. I'll call that state 6. And I believe these are all the states that I need. There's finally the accepting state. All right. So my diagram is going to have 6 states plus an accepting state. All right. I think we can do it. I think we can do it. Remember that stuff? I got to erase it. All right, let's do it. Here's my first state. State 1 is the starting state, and what state 1 said in my informal description over there was simply mark A and move to the right. So I'm going to go into state 2 here by marking A. That is A bar to the right, right? You see A on the tape, you change it to A bar. That's what I meant by mark A, and then move to the right. Okay, from state 2, you're going to continue moving to the right through any other A's or B bars. And so that's a little loop like this that says A, R, B bar, R, right? We're just moving right through A's and B bars. Finally, when you get to a B, you change to a B bar and continue moving to the right and go to state 3. So I'm going to put 1, 2, 3, 4 kind of in a loop like this, just so you know where the states are going to go. And I'm going to put 5 and 6 down here. Hopefully we can fill this in. State 2 means you're moving to the right through a bunch of A's, also through some B bars. And then finally you see a B, and you bar it. You mark it, B bar. Continue moving to the right. And now we're in state 3. State 3 is going to go move to the right past any B's and C bars. So this one is going to go through B's and also C bars. And when it sees a C, it will mark it. And then, so this says C bar. And then it can start moving back to the left, right? When you finally go out and you see a C, you mark it. And now you're going to go back looking for the first A bar. So this step 4 is moving to the left over and over again. And it has to go through a whole lot of stuff. It has to go through any C bar to the left. Also through any B's or B bars. So BBL, B bar, L. Also through any A's, L. And if you see an A bar, then you should move to the right and go back to state 1. So this should be A bar, R. All right. This here is the Turing machine diagram for that first sort of main, what I call the main loop of this Turing machine. All right. This is what accomplishes all of the markings that it needs to do, moving back and forth. The end game is after all the A's have been marked, it must proceed to the right and just verify that everything else is marked, and you see a bunch of marked B's first, followed by a bunch of marked C's after it. So, and I said, if you're in step 1 and the next thing you see is B bar, that means that all the A's have been marked. So from here, it's going to say B bar, R. If you see a B bar from the starting state, you should keep it like it is and move to the right. And then in state 5, we are repeatedly moving to the right, checking that all you see are B bars. So this is going to be B bar, R, until you get to a C bar. And when you get to a C bar, you go C bar, R. I'm just moving to the right through any more C bars. C bar, R. What? I put the things, do the things right. Like that, right? C bar slash C bar comma R. And then the signal that you're actually done and everything was marked properly is if you get to a blank from this state. So here I'm going to say BBR, and this is our accepting state. And that's the Turing machine diagram. There's actually one very small technicality. This language includes the empty string also, but actually, according to this diagram, the empty string will be rejected because from state 1, there is just, you have to either read a A and go over here or read a B bar and go down here. There's no way to get to the accepting state if you have the empty string. So we need to add in one sort of technicality state. I'm running out of room here. Would you mind if I just mar this whole diagram? I'm just going to draw it right across the middle. So there's one more arrow we need that does that. Hopefully on your paper you have more room. I was going to go around and down the bottom, but I ran out of room. This one just says BBR. The only way that this can actually happen is if we begin with the empty tape, but that should be accepted. And so if the thing really starts with an empty tape, then you're going to read a blank immediately from the beginning, and you should immediately go to the accepting state. All right, this is a Turing machine for this language, A to the N, B to the N, C to the N. It's a little complicated, as usual with the Turing machines. One thing that this means is Turing machines are more sophisticated than stack machines, right? A stack machine can only accept context-free languages. This is a non-context-free language, and you can accept it on a Turing machine. All right, next time we're going to talk about just sort of what kinds of languages can you get from a Turing machine. Can you really get anything, or are there still some restrictions? We'll talk about that next time. I want to do 2 more examples. All right, next example, I would like this language. This is also an example of a non-context-free language, although this is actually not easy to show using pumping parse trees that it's not context-free, but it turns out it is not context-free. XCX, where X is in A, B star. So this means any string followed by the letter C, followed by that same original string again, all right? This is not a context-free language, but it is a language that you can do on a Turing machine. XCX, Charlie. I'm going to do a similar kind of Xing matching strategy. For example, a string which is in this language would be something like A, B, B, A, C, A, B, B, A, right? It's something followed by C, followed by that same first thing again. And this one you can do, again, by marking. This idea of marking things on the tape is a pretty powerful strategy. It doesn't work in every example, but it works in most examples that we're going to do are going to be based on marking. And the idea is you begin with that string. You start by Xing out the A. Now you could change it to an A bar, but actually it's not important to remember if that. The problem with Xing it is sometimes you want to remember that it used to be an A. It doesn't matter in this example. Then you move yourself to the right until you pass the C, and then you're going to X out that A. So the next step, according to what you see on the tape, would be that. All right. And then you go back to the beginning until you encounter this, until you go, past the C and then hit the X, and then you're back at the beginning and you read this one and X that one. All right. The difference between this and the previous examples that we've done is if we X'd a, then later on we should be looking for an A to match with it, to X out. And if we X'd a B, then later on we should be looking for a B to match it with. Actually, this requires, so we'll need, I'm going to say something like 2 parallel routes in the Turing machine. All right? I think you'll see what I mean. Let's try and describe what the steps exactly should be. I'm going to, maybe we'll just talk through this example like I did last time, but I'm going to move everything over so I don't run out of space again. So what I just wrote, can I make it a little shorter? How about just A, B, B, C, A, B, B. All right, the strategy is you X out this A, then you go B, B, C, A, B, B, and then you move yourself to the right, and then you're going to once you pass the C, then you're going to X out the next A. So the next step of this will say A, X, B, B, C, X, B, B. All right? So if I were to write this in words, what I would say is you read the first letter. You read and mark the first letter. By mark, in this case, I just mean turn it to an X. You could put the bar on it, but it's not necessary. So read and mark the first letter. And then you move yourself to the right, past any A's and B's, right? You're going to move yourself to the right until you hit the C. The C actually helps you in this language. You know, the C is not necessarily in. Why did I put the C there? Well, that's just how the example is. But actually, the C is helpful because the C is like your signal that once you pass the C, then you're going to start to look for things to mark. So move to the right past A's and B's. And then when we pass the C, now we start moving to the right, but only through X's. And the very next letter, we're going to mark. So when we pass C, we move to the right through X's. And then if we encounter the next thing, which is not an X, if it's the same as the original marked first letter, then we should exit and go back. If it's not the same, then we should stop and reject the string. So move to the right through X's, and then I'll say if we read the same letter as above, whatever the first letter that we read was, if we read that same letter again after the C and a bunch of X's, then we mark it. And then we move to the left, right? And we're going to continue moving left a whole lot of times. Past X's, move to the left past X's. Then, so that's when we're moving through the second, half of this string. We're going to move past a bunch of X's. Then we're going to pass a C, and after the C, we're going to move past a bunch of A's and B's. So we move left past X's, then we move left past a C, a single C, and then we move left past A's and B's. And then when we see X, that finally means we're back at the beginning and we can go back to the beginning of this main loop. You loop back to the beginning of this whole procedure. All right, this one's a little complicated. Anyway, what is the signal that we're done? The end game, as we say. When we're actually done, I'll say ... right? In this example, eventually we will get down to this format. So if you go back to the first state and what you see is a C, that's a signal that you're done. So in state 1, I ran out of room again. I got to do it over here. Sorry. In state 1, if we read a C, that means we're in the end game, and you shouldn't immediately accept them because there may be leftover letters that you didn't yet mark all the way to the right. So we have to verify that the right-hand side of the string is all X's at this point. So in state 1, if we read a C, we're going to move to the right through any X's, and then if we see blank, then accept. Right? That would indicate that the second half of the string has all perfectly been matched with the first half, and we can finally... All right, let's try to identify what our states are. We're going to read and mark the first letter, so that's actually the first state by itself. In this case, I had an A, I changed it to an X, so that's going to be state 1. And then we move to the right past any A's and B's, and then when we pass the C, we move to the right through X's. So we actually need two separate states for that. One of them is trying to move through A's and B's repeatedly with a little looped edge. The other is trying to move through X's repeatedly with a little looped edge. So I'm going to say this is going to be state 2. We're moving to the right past A's and B's. And then when you see a C, you shift into this state, which is moving to the right through X's. And then if we read the same letter that we did in the first step, we mark it and move to the left. So actually all of this can go in one state. That's because this state has this as a repeated step. When you see X's, you do this thing over and over again. But if you read this one letter again, then that will just mark it and then move a single step to the left. And then go into the next state. So this is all, I'm going to call that state 3. And then here, move to the left repeatedly past X's, so this, and then move to the left past 1C. So this can go sort of in one step. I'll call that state 4. And then we move to the left past any A's and B's, and when we see an X, we go back to the original state. So this is state, I will call that state 5. And then it has an edge that goes back to state 1. Now, here's the trick. In this example, like I said, we are reading and marking some letter, but the behavior is different later on depending on what letter that was. If I marked the A in the first step, then in this step I need to read an A and mark it. And if I marked a B in this step, then down here in this step I need to mark a B. How do you remember which one you did in the first step once you're down here in state 3? The answer is you can't really remember. The way to make a Turing machine behave in this way is you just make two parallel branches. This is what I said before. So state 1 is not actually going to go to a single state 2. I'm going to call these 2A and 2B. So 2A is the one in which we read an A in the first state, and then we will go into state called 2A. If we read a B in the first state, we will go into state what I call 2B. They're just like two clones of each other. The behavior is going to be the same, but I made these two separate clones so that we can remember which track we're on by the time we get to state 3. So state 3 also has two tracks because they behave differently. 3A and 3B. So 3A is the one in which we originally read an A, and in that case we're going to mark an A. 3B is the one in which we originally read a B, and so we're going to mark a B. All right, but both of those can go back to state 4. By the time you get here, we have already dealt with the branching behavior, and after that everything can act the same way. So then 4, then 5. All right, this is the idea for the main loop. What about the end game here? We just have to, I think this just requires one extra state. So in state 1, if we read a C, then we go into this. We're going to move to the right through X's. This I'm going to call state 6, and it has an arrow going to the accepting state. Let's see if we can make the diagram for that one. All right, I'm going to put my accepting state here. I sort of plotted this out ahead of time. I'll give myself as much room as possible. Here's how I'm going to organize these. I'm going to say 1. I'm going to have these two parallel tracks, 2A, 3A, going down to 4. So it could go this way, but then I have this other sort of parallel universe where you go through the B track. All right, this is what I meant by two parallel branching paths. And then 4, remember, goes to 5, which then goes back to 1. So I'm going to do that this way. This is the cutest way I could figure out to draw this picture without crossing the arrows. All right, and then we have the end game, which is state 6. I'll just put that down here, which eventually will go into an accepting state. All right, let's see if we can squeeze in the transition. So from state 1, we read something. Now, it might be an A or a B, but anyway, we're going to mark it and then move to the right. And if it was an A, we're going to go to 2A. So this will say A, X, R. And this will say B, X, R, right? So if in the first state, this is starting state. If in the starting state you start with an A, you go into this A branch. If you started with a B, you go into this B branch, right? Okay, from state 2 says move to the right through any A's and B's. And then when you see the C, continue moving to the right, but switch into state 3. So this arrow here is going to say C, C, R, because in this step we are going to have a looped edge. I don't have a lot of space here, but a looped edge, which is going to go past everything until it gets to C. So this is going to say A, A, R, B, B, R. All right, I hope you have make this picture bigger on your paper if you can. Okay, similar down here. This does the same. It's just a clone of that one. So this is going to say also A, A, R, B, B, R. Okay, how about this? 3A, this is a state in which we pass the C. We're going to have to probably go past some X's. So I'm going to put X, X, R here. X, X, R. But now we are, after you go through a bunch of X's, and then you're looking for an A, which is going to match with the original A. And since we're on the A track, we're looking for the A. So here, it's going to say A, X, and I'm going to say L. Once you mark the thing to the right of the C, then you're going to start moving back to the left. And similarly down here. So this one says X, X, R. And then this one says BXL, right? This is the track on which you're looking for a B. And when you see the B, you mark it. Start moving back to the left. All right, this is a little tricky. State 4 is moving, first of all, back through any X's. So I'm going to say XXL here. Not my t-shirt size. And then I get to a C in the middle. I have to move past the C in the middle. That's here, CCL. Why does this one get a looped edge, but this one gets its own edge into another state? The way to separate the two scenarios is this one has to move through a whole lot of X's. So it needs to keep on doing the same thing, move through an X and another X. But there's only one C in the picture that or one C in the string that we're supposed to move through. So once you pass the C, then you need to go into another state because this state is different. It's going to move through a bunch of B's and A's until you see an X. So here, this is where I'm not much room here. We're moving to the left through A's and B's. So AAL, BBL. And then when we see X, I'm going to say XXR. When you get back to an X, that means that you've backtracked all the way to the beginning, at least of the letters which you have not yet marked, and we're back in state 1. All right, this is the main loop. That's pretty complicated. This is like Hollywood math here. And now I said the end game here is if you're in state 1 and you actually are pointing at C, that means that you've already marked everything in the original string. So in that case, what we'd have to do is just run through the end of the string and make sure that everything else is actually marked. So I'm going to say, first of all, CCR. This just like moves us into the end game. When we see the C from the first state, we know that it's ready to start checking to see if everything else is correct. And from here, we're going to verify that it's all X's until you get to a blank and then you accept. So here, I'm going to say X, XR. And then if I see a blank, it's a BBR into the accepting state. And this is how we do it. Pretty fancy business. Parallel paths, that's what this one is meant to demonstrate. Of course, it also is an example of using the marking as a basic strategy. All right, are you feeling good about this? I don't know, these are complicated. I got one for you all to try, and I will give you kind of a basic strategy to try it along with. All right, here's one I want you to try. How about the language of all strings, X on A's and B's, A, B star, such that just the number of A's is equal to the number of B's. All right? That's it. Can you make a Turing machine that accepts this language? Here's my suggestion, my advice, strategy. Let's just say a typical string that has this form would be like that, a baba. I have 3 A's and 3 B's. That's what I mean by the number of A's is equal to the number of B's. What's your strategy going to be? I would suggest you just start at the beginning. If you see an A, mark it off. You might as well exit. You don't have to remember that it used to be A. And then look for a B and mark that off. So I marked the next B. All right? So I will just say something like mark the first letter. Right? Move to the right as far as you need to in order to see a copy of the other letter. So mark the first letter. Move to the right. You might have to move through some X's, you might have to move through some other versions of the first letter. You might have to move to the right through some X's you've already marked, or you might have to move through more copies of the same letter that you're looking at. I will say through X's or other of the first letter. And then when you find the opposite letter, if you started with an A, when you find a B is what you're looking for, then you mark the other letter. I mean, I hope you know what I mean. If you started by reading an A, the other letter is B. That's the one you're looking for to match up with the A that you just read. All right? And then you repeat this or mark the other letter, and then you want to go back to the left to find the first unmarked letter on the left part. All right, so mark the other letter, and then I should say that move left until you get to the first unmarked. And then you repeat this. All right, see if you can make it happen. Try and write some more detailed steps like this. This is the basic idea. Boil that down into some states. See what you think. See what you get. See how you like it. Did you do it? I hope you did it. I'm going to try and write out my answer. Let's see if you did something like what I did. Remember, the strategy is we're going to mark off the first letter that we see and then go find a balancing letter. So if we marked a A first, we go look for a B. If we marked a B first, we go look for an A. So there's going to be kind of two parallel things. Anyway, I'm going to start with my starting state, and it says if I see an A, then I'm going to exit out and then move to the right, and I'll go here to like 2B. If I see a B, I exit out and move to the right, and here I'll go to like 2B. These two states should do more or less the same thing. That is, they should continue to move to the right. This one should move to the right through any A's or X's that it sees and look for a B. So this is going to go A, R, X, X, R. Really what we're looking for is a B, and if we see a B, we exit and then start going back to the left. Actually, these can come back together. If we see a B, we exit and go left. Here is all the same, only the opposite, right? So here it's going to go B, B, R. In this case, we read a B first, so we move through other B's, also possibly move through X's. And if we see an A, we exit out and then move to the left. And then here, this state is going to continue moving to the left. Now, we have to get all the way back to the beginning of the string. Really, we are looking for the first non-X letter in the string, but since we're moving to the left, there's no way to tell if we're on the first one or not until we overshot it. So the only way to do this is to go all the way back until you hit a blank, and then move yourself to the right again, past a bunch of X's until you hit the first thing that's not an X. So this one, I'm going to make it go all the way to the left until we hit a blank. So that would say, do this. I'm moving to the left through any A's. So AAL, BBL, also through X's, XXL. You know what that is not. This, do I have to, you don't have to give them numbers if you don't want to. This will be my third state, obviously. And then once I get all the way back to a blank, I'll go into a fourth state. Actually, here's a little trick. You don't need a fourth state here. Once you go all the way back to a blank, you can just go back to state 1 because you'll be at the leftmost end of the string. So this is going to say blank, blank, R. The only problem with this is if you're in later steps, the string will now begin with an X, and it could begin with many X's, and you want to move past all those X's. So I could just add that in here, though. X, X, R. All right, so at this point, this is the main loop here. We X out one letter, then move to the right and X out the corresponding letter. Then we move all the way back to the left. Once we get to the very beginning, we see a blank, we start over again. And when you start over again, you're going to need to move past some X's at the beginning. This, of course, is the starting state. All right, and then what determines if we accept? Actually, right here, if we move past X's and we only see X's, all X's, and we get to another blank, we should accept. And that, you can just do like one of these, BBR into an accepting state. All right, that's how I did it. Maybe you did it in a similar way. Maybe, as usual, you could have done this in other ways. I think this is probably, in my opinion, the most straightforward way. I don't know if you can do this with fewer than 4 states like I did here. All right, that'll do it.